Hi everyone and welcome to this new video. In this video I continue my Linux Privilege Escalation series. In particular, in this video we will analyze how to do SUDO exploitation. That is, how to use the sudo command and the sudo subsystem in order to do privilege escalation and obtain root privileges. So this is the basic idea. The video is structured as follows. We have a Docker setup, so I prepare a really simple Docker image to play around with sudo. I will explain what is sudo. I already did that in the Linux permission video, but we will do a review to understand how does it work, what it is, and why it can be used to do privilege escalation. Then we will analyze how we can configure sudo, because the idea is that SUDO exploitation has to do with misconfiguration of the system. So we will analyze how to read the sudo configuration and how to understand if a sudo configuration is vulnerable or not. And finally, we will do some sudo exploitation. So some practical example. I prepare 4 examples in which we're going to exploit the sudo command. And then at the end, I leave some reference. So I hope the video is going to be enjoyable and useful. If you like it, please leave some feedback, share with like-minded people, and subscribe to the channel to support me and future videos. That's it, enjoy the video. So as always, I like to play with Docker, with having some simple Docker file. In this case, to play around with sudo, instead of changing the configuration of our Linux system, of the system we use, it is much better to just play with sudo and change it there, destroy the container, and that's it, so we don't have to worry about it. So I prepare a really simple Docker file, this Docker file. I literally just get the latest image from Ubuntu, I do the update of the repositories, and then I install sudo and nano to edit sudo. Finally, this is an important step, I set the password of the user Ubuntu, which is the default user of the machine, to the value test. So we know the password of Ubuntu, and it's gonna be critical. So this is the Docker file, how we can build it with this Docker build command. So we go into the directory where we have the Docker file here, and then we do sudo, let's split it like this instead. We're gonna do this sudo build. I already built it. Then you can just run it. We do sudo run. I always give a name to my container, and I also use the option --rm. This means that the container is gonna be removed once I stop it. This is useful for all those containers that you just use for quick tries, so that not containers that hold services that you want to persist through the various stop and start, but containers that hold no really important information, so you can just delete them and create them new. So this is the idea, and then once we run the Docker, we can go into the Docker, we can obtain a shell into the container with this docker exec command. All these commands that I'm showing are gonna be available, just follow the links in the description, everything will be available to you, so you can also play around with it. So we do docker exec -t sudo lab is the name of the container, and then the command we want to execute, which is /bin/bash, which is our shell. So we do this, and notice the hostname change, the username change from Leo to root. It means we are inside the Docker. So at this point we can play around with this, we can do commands. So of course right now we are root, and we have a user in this machine, because if you go into the /home and we do ls, notice that there is an Ubuntu directory. This signifies that there is an Ubuntu username. We can also understand this by doing a simple cut of the etc passwd, because this file contains all the users of the machine, and in the last line of this file we see a line that starts with Ubuntu. So this tells us, look, there is a user that is called Ubuntu. So that's really important. So this is the setup, so we can review what is sudo and how we can use it to do privilege escalation. So what is sudo? Sudo stands for super user do, and it is an important subsystem. It is an important utility that relates to the way that permissions are managed in Linux distribution. For example, whatever distribution you use, sudo is sort of like distribution agnostic, It means that you can use it in Arch Linux, in Ubuntu, and in many different distributions. Essentially, any distribution supports the sudo utility. So the idea is that you're gonna have to download it initially. So you can do it, for example, with the pacman package manager or with the apt. So depending on the package manager, the download command will be different. In this case, it's apt install sudo in Ubuntu. And then, once you have installed it, you can say, okay, where is it in the file system? And it tells you the path. Now, the way you actually use it is, first of all, you have to understand how it was configured. Because this program, in its essence, allows you to execute specific commands as different users. Now, here it says super user do. It's sort of like saying, okay, do this action as a super user, but actually in its most generality, sudo allows you to execute a command with a different user. Not necessarily the root user, so like not necessarily the super user of the system, but also as a simple other user. So for example, if I am the user Leo, and there are also the user Ubuntu in the machine, sudo could allow me to execute a specific command as the user Ubuntu. So this is the idea. Notice, I'm not executing any command as the user Ubuntu, but only a specific set of commands that have been pre-configured. This is why the first and most important aspect of understanding sudo is understanding how it was configured, because different configurations could be either vulnerable or not vulnerable, depending on how they are configured. So how do you check the configuration for your particular instance of sudo? The idea is to execute the command sudo-l. It sort of stands for sudo list out the configuration for my particular user in the sudo subsystem. Now, the first time you execute this command is actually gonna ask you for a password, and specifically it's gonna ask you for the password of your user. So if I'm executing sudo-l with the Leo user, it's gonna ask me for the password of the Leo account in the system. If I'm executing it with the Ubuntu user, it's gonna ask me for the Ubuntu password. Now, this step is really important because it is used for authentication purposes. The idea is that this system, this subsystem, the sudo subsystem, can only be used after a proper authentication. So you need to know the password of your user. This means that if you get a reverse shell on your target, so you get code execution on your target and you get code execution as a normal user of your system, you are not able to immediately abuse the sudo functionality. Before doing that, you need to authenticate. You need to find the password of your user. Conversely, it means that if you, for example, find an SSH login with the password of a user, so you know the password of the user and you obtain execution on a remote machine, the first thing you should always do is do a sudo-l to check how sudo was configured. Because if it was misconfigured, then you most likely have an easy way to do privilege escalation. So for example, if you are doing the OSCP exam, you get inside a machine and you have the password of the user, or in your traveling, in your machine, in your walkthrough, you find at some point the password of the user, then you must enumerate the sudo-l attack surface, because it's really important. So what happens when you do a sudo-l, for example? Well, you will get an output like the following one. So you would get matching default entries for root on system. So it says, this is how the sudo was configured for your specific user in your specific machine. This means that different user might have different sudo configuration. So if you get access to one account and you do sudo-l and nothing cool comes out of that, nothing usable, then if you get into a different account, you have to redo once again sudo-l, because different accounts can have different configuration. In this case, we are seeing the configuration for the root user of the machine. And specifically, the interesting part, so this initial part is not really that interesting. Essentially, it's saying how it is configured to be used. So like, for example, this mail bad pass, it's saying, if you use the sudo system and you forget the password, you put the wrong password, a mail will be sent to the administrator of the machine. So that's the idea. And this env reset instead is telling you that the new command, the command that you execute through the sudo system, will be executed with a different environment, with a more minimal and validated environment. And when I mean environment, I'm referring to the environment variables. So it's gonna mean that the new command will be executed in an environment with less variable and with variable with control values. For example, this secure path here, it's specifying the path variable that will be used to execute the sudo command. And why is it important to secure this variable? Because if you remember, I made a video on path hijacking. It is a technique in which the attacker changes the path, and by changing the path is able to trick the program into executing a malicious binary. So in order to not allow this sort of attack, this path hijacking attack, the commands that you execute as sudo are executed within a control environment. So that's the idea. And finally, this is the most important part. The first line are always the same. You shouldn't really care that much about them most of the time. However, the things you really care about is this. It's saying, look, your user was configured as follows. And then here we see a bunch of all. Essentially, it's saying we can execute all commands as all users and all groups. Sort of saying you can do whatever you want in this system, which is of course a very positive thing. It's a very cool thing, but it also makes sense, right? Because we are just the root account, so there's nothing special about that. Now, if you're interested in reading the configuration for the sudoers, you can go into /etc/sudoers. So for example, in our Docker machine here, if I do sudo -l, I get the same output essentially. So I can, as a root, I can execute any command as any user and any group. So the part here within the parentheses essentially have to do with who can we impersonate while we execute the command. While the part outside the parentheses, it's about the commands we can actually execute. And the command all, the string all, is sort of like a wildcard. It says, no matter what, you can execute that. So the first all has to be interpreted like you can impersonate any user. The second all, you can impersonate any group. And the third all is you can execute any program. So we have user, we have group, and we have program. So that's essentially how we can read it. And so as I said, the configuration file is in /etc/sudoers. So we can understand how we do sudo configuration. So let's say that we want to edit this file, because let's say that, for example, in our Docker, if I do cat etc sudoers, I get all of this. So it's like all of this stuff. I redo it, cat etc sudoers. Actually, let's open with less. I think it's gonna be more clear. I don't have less here. Maybe let's install it. Let's hope nothing breaks. Okay, I'm downloading it and I do less etc sudoers. Okay, first I need to do a clear and then I do less etc sudoers. Perfect. So we see the actual file. So this is how it starts with this file must be edited with visudo command as root. And then it starts with the definition for the defaults. So it says reset, mailbed path, secure path. So those are the things we already saw. Then if we scroll down, we see a bunch of comments, like all these lines are just commented because they have these hashtags essentially, which is like a comment. And then at the end of the file, we have the juicy part, because at the end of the file, we have this include, which includes other file in the configuration. And then we have this root, and then the all equal and the thing that we saw. So the idea is that this is saying, okay, apply this configuration to this particular user. So it's sort of saying, okay, apply the configuration which is on the right side of the line to the user on the left side, so to the root user. And the configuration we saw is, so there is this parenthesis here and this all. We already said that this is user, the first all, group the second, and program the third. But then here we see a fourth all, which is before the parenthesis. Now this fourth all actually represents the host in which we can actually execute that sudo command. And all means any host in the network. Why? Because sudo can also be used in setup where the machine is connected to other machines and they share the same authentication mechanism. So you can be a user on one machine, but you can also log in other machines. In this case, it makes sense to also have an identifier over which host you can authenticate with sudo, essentially. So in this case, it's all, this small joke with words, which means that in any host, you can impersonate any user and any group to execute any program. So it's literally saying you can do whatever you want. So this is interesting. And then we see these other two lines, which are also extremely interesting. Now, they are essentially the same. However, they do not apply to single users, but they apply to groups of users. It means, for example, that every user of the admin group, once again, is able to execute all programs as all users, and any user of the sudo group is able to execute all programs as all users, all groups, and as all hosts. So to specify a group, we actually use here the percentage sign because it is a group. And essentially, this is the basic idea of the configuration. So for example, we say we start from the initial flags. This I already discussed. And then we have the thing where we specify the policies that have to be executed by sudo, essentially, that have to be implemented by sudo. So when we do something with sudo, sudo is going to look into this file to check if the action we want to take is actually allowed and authorized or not. So these policies specify how the sudo command will be used and what different users can do with the sudo command. So the rules are checked in order and the last rule that matches is used. Actually, on this part I cannot guarantee which is the last rule or the first rule, but the idea is that if you have multiple rules that can apply, there's going to be someone who decides, okay, which one do we actually apply? So in this case, it could be the last one. I cannot guarantee 100% on this. You can do some experiments to figure it out. It should be fun. So the structure of the rules is as follows. So we have the user or the group on which this policy applies. Then we have the host name or the keyword all, meaning all sort of host names. Then we have the equal sign. We have the identification for the impersonification. So this could be a single line, for example, all, which represents the user, or we can break it into user and then colon group. And finally, the command. So this is like the basic syntax. On top of this basic syntax, we can have sort of modifiers, which modify the way the policy is executed and enforced. So for example, if you consider the following line, here we are applying a policy on the user Ubuntu. We are saying, look, on any host, you can impersonificate any user to execute any program. Notice, however, that between the parentheses and before the final all, which represents the program that can be used with sudo, we find this NOPASSWD and colon. So the idea is that this says, look, you can execute on any host any command as any user without supplying a password every time. So specifically, the first all refers to the host, the second to the target users, the last to the allowed commands, and the NOPASSWD is an extra option to not require any sort of passwords, which can be really, really useful. Because other times, it can also be like, I can also ask you for a password, essentially. So depending on how it is configured. In this case, it says, look, you do not need a password. Now, if you want to edit the configuration file for the sudo system, we said that this configuration file sits on the etc file system. So we have like the etc sudoers, it is a file. So technically you can just open any file editors like Nano. You can go here and you can just edit it, right? However, to make sure you don't edit it in a way that breaks the sudo program, you should actually use a specific program called visudo. Now, why is this important? It is important because if, for example, I edit this file and I introduce a syntax error on how the configuration is written, so for example, I forgot to close a parenthesis here, I leave this parenthesis open, what happens is that the sudo program, when trying to read and parse and understand this configuration, is going to have a problem. It's not going to be fully able to understand it, so it could mean crashes, it could mean the sudo does not work anymore. To avoid this, what's the idea? we don't edit it as normal text editor, but before editing, we use the program visudo. So we use visudo to edit the file. Now this is useful because the program visudo will warn us if we have edited in the wrong way, if we have left some syntax error. So it is extremely useful to do it. Now to see some configuration, we're now gonna see 4 different examples of what we can do when we have a vulnerable sudo-l. Once again, for the sudo-l, a critical resource is represented by the GTF of beans. Now this is already discussed about this in the video about SUDO Exploitation, which is different from sudo. However, in the same website, there's also the filter for sudo. So what does it mean? It means that if you have sudo capability, you just write the name of a program, or like here you can see a bunch of programs that will allow you to escalate your privileges in the read, write, or execute, depending on the program, using sudo. So for example, if I can use a sudo and I can do base64, which we're gonna see at the end of this video, we're gonna be able to read root protected files, which is really critical because we have a read level permission of administrator. We could read private SSH keys that could do a lot of damage. So of course, the key idea to understand here that similar to the SUDO exploitation, which was heavily dependent on the logic of the binary, here is the same thing for sudo. Depending on the binary on which we can execute sudo, we can do different things. Depending on the way that the sudo file is configured also, we can do different things. Because sometimes, and this is really interesting, within the sudo, we don't see just the name of a program. We also see the pattern of usage of that program. So consider this example. Here we have a look. You can execute the command sudo pip user bin pip install as the user root, and here we have a wildcard. Now this means essentially that here you can put anything after the install. So if you find a series of options that have this initial pattern and that allow you to get code execution, then you have a privilege escalation. But the important thing is that sudo just makes sure that the first part of the program is as it is written in the configuration file. If it doesn't start with user bin pip, but with another thing, it's not going to be valid and you won't be able to use it with sudo. However, if it does start with user bin pip, pip, and then with install, then you can put anything after that and you will be able to execute that as root with sudo. So the art of SUDO exploitation is to understand the pattern that you're given and what you can do with it. And so to this end, we're gonna see 4 examples. Of course, there could be 1,000 different examples here. The idea is just to understand how this works. So as I said before, to exploit sudo, you have to enter into this mindset that anytime you get access to a shell into a system and you know the password of that user, you should always execute a sudo the shell to understand how sudo was configured in your machine. When you understand how sudo is configured, you know, okay, maybe I can use it to gain privileges or not. So this is the idea. So we start with this first example that I've actually showcased already in the bashed walkthrough of ActedBox. Now, ActedBox is a great resource because the machines in ActedBox are filled with these kind of practical steps. And for example, in bashed, once we got a reverse shell into the machine, we were executing as www-data, right? So we were executing as this particular user. And then when we did sudo the shell, we were actually able to obtain this configuration. So we are able to obtain this configuration, and in particular it says, look, you can execute the following commands on bashed, and we were able to execute all commands without password as the user script manager. So in this case, it was just clear what we needed to do, essentially. So how would you exploit such thing? Well, the idea is that let's reason about it, right? So we are executing as www-data, but we can execute any command as the script manager user. So this is a sort of privilege escalation where we switch from one user to another, from www-data to another user, which is script manager. And we don't even need a password for doing this, which means that we don't even need to authenticate with the sudo the shell system to do this. The idea is that we just do the sudo the shell, we understand this, and then the actual exploit is the one as follows. So we use sudo, because of course we have to use the sudo subsystem, -u script manager, which means you're gonna impersonificate this user for the next command. So it means the next command you will execute as the user script manager. And what is the next command? Well, we have free choice over the next command. And so we do, look, call a shell, a pty shell with Python. Now, this particular pattern, python3 -c import pty.spawn bin bash, is used to set up a full working shell with a pty, which is like a communication channel that is robust. So it's like a really known pattern when doing reverse shell, when upgrading your shell to a normal shell. But we could put any command there. We could have put a command for another reverse shell. We could have put anything, essentially. The idea is that with this configuration, we can execute any command as the user script manager, which is extremely powerful. So this one, I won't even show an example, because if you check the bash walkthrough, you already see this in practice. So let's continue with the second command, which is actually more interesting. So in the second command, which was taken from a different out-of-the-box machine, the idea that I did not bring this time to the channel, so this is like brand new. The idea is that the sudo subsystem allows us to execute the pip command. And in particular, we can do usr bin pip install anything here. So it is not specified what we can install with pip. We can install any command whatsoever. So suppose that we have this configuration of sudo. It allows us to execute the pip command with a wildcard. So we can continue the command however we want. So how do we do this? Well, the idea for the exploitation essentially is to simulate the installation of a package. We're actually going to install a package. However, this package is minimal and it is malicious. Specifically, this is the structure of the code of the package. I took this as an inspiration from the following GitHub repository. So I want to thank the author 0x00 and I just sort of like stripped from everything in the repo. In the repo it is a bit more complex. I just took the main portion to understand how to hook into the installation process. So the idea is that we're going to do this. We're going to hook into the installation process, and in this function, in this method run, we're going to execute whatever we want. And the idea is that this execution will take place as the root user. So let's do this exploitation. Here I have my shell on the left. So what do? I do this. I create a folder named test, which is going to contain our malicious package. I enter into this folder. I create a touch setup.py, so I touch a file, which means I create a file. Then I edit this file with the following code. So this code is gonna hook into the installation process, and I'm gonna save this. So essentially we're gonna hook into the installation process, and upon the installation, we're gonna execute this install.run, which is normal Python code to install packages, but also we're gonna do os.system whoami redirect to tmp test. So we're gonna execute the whoami command, and we're gonna redirect the output to the /tmp/test. So how do we trigger this code? Well, the idea is that we go inside the folder here, and then we do. Remember that we have to satisfy the pattern configured in sudo, so we do sudo usr bin pip install. Now at this point here there's a wildcard, which means that we can continue however we want, and the idea is to do --upgrade --force reinstall. So we execute this, and let's see what it's gonna do. It's gonna do like it's gonna create some problem because of a thing with the pip. But however, it says, look, if you want to ignore this error, you can just add the flag break system packages. And just to explain, this error has to do with the fact that pip before allowed you to install packages in the global repository, so in the global system. However, this led to various dependency problems. So in order to avoid this now, they don't allow you to install into the global namespace unless you explicitly say so with these break system packages. So I do this, and notice what happened. It installed the package test, and if we check into the tmp directory, we get a test folder, and if we check here, we get the root. So we are actually the user root. And to make sure that we are the user root, we can also do this. let's go into the user directory here. And I'm not sure if we have SSH keygen. Okay, we don't have it. Let's try to install it. SSH keygen. Probably not like this, right? Probably I just have to do SSHD. What if I do SSHD? Open SSH server. So I'm trying to remember how to install the OpenSSH server. So we're going to install a typical OpenSSH server. We're going to generate an SSH key and we're going to read it using this method, just to showcase a little bit of more complex like technique that you would do in a privilege escalation. So now I should have SSH keygen. Yes, I do it. And the way we can use it is SSH keygen. Then I do, I think it's TRSA, and then I do D, and then I do, let's see if I do like this. Okay, it's gonna say, okay, I'm gonna generate a private public RSA key. It's gonna tell me where to store it into the SSH directory, no passphrase. Okay, so it has generated a key here. So this is my SSH private key. And now I am the user root. Let's steal it with the user Ubuntu. So I am into the user Ubuntu now. Of course, I cannot access the SSH key because it says permission denied, right? But now we have execution as root. So what I did now is I changed the command that we execute once we install the package. Instead of just printing who am I into the TMP folder, now instead I'm reading with cat the SSH key of the root user, and I'm printing it into the TMP folder. So that's the new idea for the attack. So we can sort of like do it the same way. So let's remember the command here that I use is this one. Of course, notice that TMP now is just with test. So I execute this command and I have to actually add this extra flag here. So let's write it here, and I'm gonna also note it here. So it installed the package. Now we go into the TMP. Notice we get a TMP DRSA, right? So we do TMP DRSA and boom, we have our private key. So we have stolen the SSH key of the root user, and this is a typical path for privilege escalation, because with this SSH key we can log in into the user. Now I do not believe that the SSH server is running. So what if I do SSH DRSA root localhost? I don't think it's working because it's not running the server, so we cannot do that. Maybe in a later video I will show how to deal with SSH, but the point is that we were able to read a critical file as root thanks to this exploit. And to recap what we did with pip, the idea is that the sudo configuration allowed us to execute this command as root. However, this command was not fully specified because there was a portion that was missing, this wildcard, and it allows us to expand that portion with whatever we wanted. So the actual exploit was this: pip install dot upgrade force reinstall break system packages, and this dot was done into the directory in which we had created a malicious setup.py, which during the installation process executed an arbitrary command, for example, who am I, but also cut off the SSH key. So this is the second example that I wanted to bring, which had to do with pip. Now moving on to the third example. This time it's going to be faster because it's a single line of exploit. Suppose that in our configuration we can use the tar command as follows. So the first thing I'm going to do now is going to edit once again the sudoers, and I'm going to put this one instead. So we don't have this pip install right now, but rather we have this user bin tar des cvf and then wildcard. So this is sort of like, okay, you can do tar as root. Now let's go into Ubuntu. Let's do a sudo l, and now notice it is not the user pip install anymore that we can use. It is the tar command that we can use. So how can we exploit this instead? It is much easier because it is a single line and we don't even need any extra script or whatever. So the line is this. We're gonna do a sudo tar. Of course, here it's gonna put the entire path. Then we're gonna do cvf. We're gonna put exactly the way it was configured here. And then here we're gonna put this devnull. We're gonna put a checkpoint, and we're gonna put a checkpoint action. The idea is that during the tar process, during the creation of compressed archives, which is the objective of the tar command, we're able to execute actions depending on certain checkpoint. And in particular, it says, look, every time you find a checkpoint, you execute the command bin sh. And since this command is executed as root, we will have a bin.sh as root. So let's execute this. And notice what we get. Easily, we went from Ubuntu to root in no time in a single exploit, in a single line. And for example, if here we change from bin.sh to bin.bash, here we have a full root shell. We can go into the root directory, into the SSH, and we can once again read the private key of the root user. So this was a simpler example to showcase how dangerous that is to be exposed in the sudo configuration. So that's the idea to understand. The sudo subsystem itself is secure. What matters, however, is how we configure it. It's the specific configuration that is done on the machine we are trying to do a privilege escalation over. And for example, in OSCP-like box, in active box machine, in CTFs, and sometimes even in penetration test, it happens that you find machine with misconfigured sudo. For example, in this case, this is a misconfigured sudo, because by abusing the tar binary executed as root, we're able to obtain like a privilege escalation. We're able to execute any command as root, and therefore also the bin.bash command, which is a full-fledged shell as the root user. And so we can move on to the fourth and final example, which is gonna be base64. So let's say you can execute just the command base64 with no extra flag. So this is just the command base64, and of course with the file that you want to apply this base64. So what can you do with this? Well, the idea is as follows. So let's essentially let's do this. Let's put this into the configuration. So I go this, exit, I do visudo, I go down, and here I put not this star, wait, I have to go down, not this star, but user bin base64. Perfect. Then I go into Ubuntu, as always. I do a sudo -l. Notice now I can say, look, I can execute base64. Now in this case, we're able only to read file as root. We are not able to execute arbitrary programs as root, because base64 is used to read a file and compute the base64 of that file. It is a specific type of encoding. So for example, we can say echo, we can go into base64, and it's going to compute the base64 of this particular string, of the echo string. We can also apply that to files. So for example, let's say that I have a file. Let's say I create a file like test.txt. Hello, please subscribe. This is an example to showcase the base64 binary. Then I save the file. So this is my file. It's actually cat test.txt. So how can I base64 the entire file? I just do base64 test.txt, and here I have my base64. If then I want to decode it, which means going from base64 to the text content, to the original content, I can do base64 test.txt, and I can put it into a file, encoded test.txt. So this is the encoded thing. And then I can take this and I can apply to base64-d. It means decode. So the idea is that we have some text, then we do a base64 of that text, and then we do a decode of that text to go back to the original text. Now the same thing, of course, can also be applied to the sudo. The idea now is that not only we can use the base64, we can use the base64 with root privileges. So what's the idea here? The idea is to do, okay, we do sudo, we do user bin base64. Here we put the file we want to read. For example, root ssh edrsa. And notice here what we get. We get not the content directly, we get the content in base64. To actually get the content directly, we just have to add a pipe and say base64-d to say, like, after you got the content, I want you to decode it. And so here we see the line private key, we get the actual private key. But of course, even if we didn't do the second base64, we can take this base64 and we can use any decoders. It's practically as if we have the original bytes, because it is not an encrypted layer. It is a simple encoding layer which can easily be undone. We can easily remove the base64 encoding. And so this final example showcases when we cannot fully execute code However, we can still read files as root, and this can be dangerous because we can read configuration files that maybe contain a plain text password. We can read, for example, the etc/passwd file. So another critical file, right? Because let's say that we are root and I want to read here the etc shadow. I want to read the etc shadow, not etc/passwd, sorry, etc shadow. Now this file actually, if I decode it now, this file contains the hash of the various users. So in this case, the only hash that is actually present is the hash of the Ubuntu user. Everyone else is not there because we did not set the password for those accounts, but still, the etc shadow file could be a very dangerous file to lose, especially if the users have weak passwords that can easily be cracked. So that's the idea. So with basic-c4, we can just read essentially any file. So this is it. I have some reference here. I'm gonna put in the description into the functioning of sudo, into the GTF of beans. So this is like a critical resource that you should use. This covers everything for this video. I hope you got the idea of what SUDO exploitation is all about. It is all about understanding how sudo was configured in your machine and to exploit the misconfiguration. Understanding, okay, I have pip program, I can use it in this way to obtain privilege escalation. To this end, once again, I cannot recommend enough this GTF of beans because it contains how you should exploit each binary assuming you have sudo capability over that binary. So this should become your best friend when doing privilege escalation in Linux. So this is it for this video. I hope it was enjoyable. I hope it was interesting. If it was so, please leave some feedback. Tell me what you think about it. Tell me what I've missed or what you want me to cover in the future, and to the next video.